looks like we are good. Good to get started here. So, getting ready for the exam. So, just want a couple things to point out. Notice you've got this exam prep coming up. So, one person has commented in there. It's a graded assignment. So, just make sure you go in and leave some kind of meaningful comment in there, right? Something that actually may be helpful in some way to yourself or to other people. So, you leave a comment so I can grade for that, right? That's great. That's an easy 10 points. Easy 10 points. Well, it'll take you 5 minutes and it's worth points, right? That'll go into the homework category. So that'll help you out with that. So keep that up. And then we are looking at stuff for the test. So I want to explain some things about the exam because I want to make sure no one's confused because there's potentially a retake. If there are people who need to do the retake, that'll be next week. But if you mess up this one, you don't get to try this test again and get the retake. If you mess this up, you'll just do the retake, right? So I think I have the test set. If I have it set right, it should go live at noon today. So that's well after our class. I didn't want it up during class. That could be, cause some issues. So it will come up later today, and then you can start working on it. So you have to have the test completed by Sunday night. Okay, so Sunday at 11:59, it's due. You will not be working on it anymore past that. I have had students in the past trying to finish stuff at the last minute, and they're like, oh, it didn't allow me to finish. Right, you've got 5 days to do it. Don't be doing it at that last minute. So you can do it at any time over that 5 days, but that doesn't mean you can't start it today and then finish it Sunday. That's not how it works. Once you start the test, you have a limited time. Now, it's a bunch of hours. I think I put 8 hours, right? So once you start the test, you have 8 hours to finish it. So you can't do 2 problems today, 2 problems tomorrow, 2 problems the next day. It's not going to work that way, okay? You start it. You've got 8 hours to finish it and get it done. Now, it's not going to take you 8 hours, or it shouldn't. If you've been doing the proper stuff along the way, it shouldn't take you anywhere near 8 hours. I think the estimated time because in these softwares, when we create assignments, they give us an estimate based on previous students who have done that problem. It times them. Basically every move you make in the world today is being tracked by someone, right? The apps on your phone are tracking you constantly. Even when you're doing your homework, the software is tracking everything you do. Now, the good news is it's not like, Facebook and Google and Apple, when they're tracking everything you do, they're trying to monetize and make money off of it. When Delta Math tracks you doing the homework assignments, it's really just trying to create a better platform. So basically what it does is it estimates, here's the average time it takes students to do this problem. Here's the average time it takes students to do this problem. That's really the kind of data that they're collecting when you're doing problems. So it can basically, when I'm creating a test, it can give me an understanding of this is about how long it's going to take people to do this test, right? On average. And it was an hour. So, very reasonable for you to complete this assignment in an hour. Many of you will have it completed in an hour. Some of you will take a little longer than an hour. Sometimes I have people who take, they really just take their time, maybe 2 hours at the most, but that's once every couple of years I get a student like that. But you got it. So you have 8 hours to work on this once you start it. So that's some of you could go through, complete the test, and then redo the test 8 times, and you'd still be able to work on it. It will allow you to change problems. So if you get a problem, just like on a real test, if you got a problem wrong and then you went back before you turned it in and looked at it, you could change that assignment within the 8 hours, right? Once that 8 hours is completed, no more working on it. But let's just say you do problem 2 and then you get to problem 5 and you realize, oh, I did problem 2 wrong. And you can go back and fix it, okay? Just like you would be able to do on a paper and pencil test that we had in the classroom. So I just want to make sure that subtlety is understood. You can work on it anytime between noon today and midnight Sunday, but once you start, you only have 8 hours. So you have to pick a time. So be strategic. Pick a time, whether it's morning, evening, whatever, where the kids are in bed, your parents don't need anything from you, work isn't calling you, whatever, your significant others at work, whatever it is that you need to do in order to be able to just sit down, focus on this, work through it, not have a bunch of distractions, stuff like that. Okay, so let's see. That's a good question. So it's a good question about the score. I believe it will tell you your score, but it won't give you any kind of solutions until like Monday, basically, because it doesn't want part of you to do it, get solutions. Even though the problems are randomized for each of you, it doesn't want people to be able to share how the problem's done, right? So the idea is pick out a time that works for you this weekend or Friday or Thursday or whatever works for you, where you know you're good. Set down, make a block of time, work on it, check your work, really spend some good time getting that good grade that you can, and hopefully maybe no one will even have to take the retake, right? And you have plenty of time, so don't stress out. What we find online is the less time we give students, they start stressing out and they start trying to find ways to try to cheat. What I have found generally from looking at the scores is that there seems to be less cheating when I give plenty of time, because students don't feel like they need to, right? So you have a choice. You can do this the right way, or, some people are going to choose to try to find different ways to cheat. I would encourage you, since you have plenty of time, try to just do it honorably. Try to be an honorable person. Try to be a good person who, does things the right way, and see how you can do on it. Worst case scenario, you take the retake next week, right? But try to really see if you can succeed the right way and get a real success under your belt, because the letter grade isn't really going to mean much if, you're going through all this work. You might as well use it to become a smarter, stronger person, right? So really try to do that stuff the right way. I challenge you to do that, sort of take it as a measure of your character. Are you able to do that? And then, try to get this stuff answered. So, and if something goes wrong, that also means, so if your internet goes out, hopefully it's only out for an hour or two, you still can come back and work on your assignment, right? Or on the test, right? And still get it done. So any of these kind of weird stuff we're having going on, power outages. Monday, I was supposed to have a power outage because they're still replacing the burned up poles from the fire in my neighborhood. 4 years late. What? 4 years later? Oh yeah, it's almost another month. Will be 4 years, right? So they're still replacing power poles. We were supposed to have the power off all day, except it rained, so they rescheduled. But we have that every couple weeks. So and some of you get that when the weather comes up, or if you live in a neighborhood that was burned up a few years ago. Sometimes the power gets scheduled to go out. Well, plan around that, and then hopefully if the power is only out for an hour or two, then you can pick up where you left off with your homework, right? If your internet goes out, right? I had that happen the other morning where I was preparing for my 8 a.m. class. I was getting all ready. 5 minutes before, it was like 5 to 8, internet goes out. Okay, great. So, 10, 15 minutes, I'm running around, resetting routers, because we have the house. There's no place where I can put one router that reaches the whole house for just because of the way the house is shaped. So, I'm going around to all the different routers on different floors and stuff like that, resetting routers. 15 minutes later, I get it working. So if something goes wrong like that for you, the internet goes down, hopefully you'll pick it up. Or you could go somewhere where you get internet, right? Darn it, the internet went out at my house. I better go to the library. I know I can get internet at the library. Do be careful about putting your, username and password into a public computer. Make sure you click that button where it's not going to save your username and password and stuff like that. But, you have options so that you can make sure you get it finished. So it shouldn't be a stressful thing for you. Let's see, question here. So students asking me, I'm not 100% sure if I understand the question, but a student is asking, if we were behind, do you think people will still do good? It depends, right? I mean, that's such a general question. How far behind? How well do you know the material, right? You have to be able to know systems of equations. You have to be able to know factoring and solving equations with factoring. Those basics, those are pretty important. Being able to graph lines and solve equations of lines and find the equation of a line that goes through 2 points. You have to be able to do that stuff. So it just kind of depends. I guess you'll find out here in the next couple days. And then if you do poorly, there'll be a retake, and you can give yourself another week or two to learn and get caught up. If you are behind, I would highly recommend make this your big priority right now to get caught up, right? Get yourself caught up. Learn how to do these problems. They're problems from Delta Math, so you're looking at the same kind of stuff you've done in homework. So if you totally understand how to do the homework problems, you should be good, right? And it's significantly shorter than the practice test. So make sure you go in and learn that material. Can you factor things? Yeah, okay, you'll get those right. Can you solve systems of equations? Yeah, okay, you'll get those right. So you can gauge for yourself from the practice test kind of how well you're going to do. If there's big sections that you're missing, man, I get it all, but I don't get systems of equations, then that's the homework you want to focus on. And remember, so I do have office hours tomorrow. Tomorrow, that's what, from 9 to 10, I have an office hour. You can hop in there and ask me questions. Also, the Ventura College Tutoring, they sent us an email. They still will set up Zoom appointments. So you can contact them and say, I need an algebra tutor at this, can we set up an appointment? And they'll say, can you do it at this time? Yeah, I'll be there at that time. Great. And then you're going to have a tutor sit down with you and help you with your stuff. Okay? So that's my understanding of how they're doing it now. That's pretty great, right? For free, you get someone to sit down and just help you with a bunch of problems that you need to work through. So, you can do that. For the practice test, that is, right? For the practice test. Right. So I'm not 100% sure to answer that question because sort of, with some people when they're behind, they're 2 assignments behind. Other people when they're behind, they're 20 assignments behind. So it kind of depends where you fall in that category right there. Okay. So are there other questions about how this is supposed to work, like administratively? So we can get to the content in a few minutes, the actual mathematics. But as far as how the test is structured, and it's not, so again, it's not the same rules as an assignment was, where you could keep trying a problem again and again. It's not like that. You get one problem. You got to make sure you get that right, of each type. So are there any questions on how that's going to work? No. No questions, it looks like. Okay, well, if there are questions, feel free to bring it up because I'm not going to see you again until after the test. So if you mess it up, then it'll sort of be too late. Of course, you can always email me, but I don't check my email a ton on the weekends. So, or really sometimes at all. Sort of depends on things. You can let me know. Okay, then transitioning over to the mathematics. What mathematics do you need to see that I can help you with, right? And hopefully people came with questions so that we can get into it, because otherwise if there's no questions, that means you all are ready to get 100%, right? So let me know.
I do have a question.
Sure.
There's a few questions on the practice test that were not even homework questions.
Let's see. Let's see. Which ones are we talking about?
There's one of them that's like, is it a function or not? And you have to answer yes or no.
Okay.
We didn't have a homework thing on that.
Okay, so some of them are related to things we talked about. So let's see. Determine if a set, is it the graph or a set of points?
I think it's the graph.
Okay. Okay, we can actually talk about both. So that's a good question. So remember, our definition of functions is that each input, each x value, has only one y value. So from that we developed what's called the vertical line test. So the vertical line test says that if you pass a vertical line, in fact, let me switch over to Desmos here. So I know a bunch of you are more than usual. People are in the Zoom, but what I'm showing you obviously will show up on the YouTube stream. So, okay, good. We're starting to see some questions come in here, so that's good. So our rule says that for something to be a function, our definition of function, if you go back to those sections, said that each x value can only have one y value, right? So if we look at, say, something like y equals x squared. The way that you would determine that from a graph is by looking at things. See how if I pass a vertical line here, it only ever touches that graph one point at a time. So what that means is each x value here, like this x value of -1, only has one y value right here. If I move this over, this x value of 2 only has one y value right here. So this is a function because it passes what we call the vertical line test, which is I can pass a vertical line over this and it only ever touches the graph once at a time. That matches our definition for a function saying that that one x value can only have one y value. The opposite of that would be this. Y equals x squared. Oops. I just said that backwards. X equals y squared. Now see here, we can see lots of points where this thing fails to be a function because I can find, and you can see as well looking at the graph, there are x values that have two y values, right? So let's look right here at say, let's do an easy one, 4. At x equals 4, here's a y value of 2, but here's a y value of -2. In other words, right here on the graph, the x value has two y values associated to it. Well, our definition of function says you're only supposed to have one. Okay, so the vertical line is actually finding the places where a single x value has two y values. And in this case, there's a lot of them. You only need one for it to fail to be a function, but everywhere I put this vertical line, it's hitting 2 points at once, meaning that thing is not a function. Okay, so that's how you tell graphically if something is a function or not. All right, now the other question is, I thought I had this open already. No, I must have closed it. Okay. The other question is, how do you do it from a set of points? So let's see. So let's do this one from the practice test. So right here, determine whether the following graph is a function. Well, can I draw a vertical line here that hits it twice at once? Yep, right here. There's a few places, but like right at x equals 6, an x value of 6 gives me two y values, doesn't it? So this thing is not a function. Okay. Oh, see there, they're passing the vertical line. Fail, 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 fail. It fails the vertical line test right when you get to that end there over here. Right? It fails it almost everywhere. In fact, there's only one point where it doesn't, right, at x equals 3. But once you pass x equals 3, it fails that vertical line test every time. All right, let's try another one. Okay, is this a function? Nope, because it fails the vertical line test in these areas right here. I can put vertical lines right here, and I hit it twice. Think about x equals 1. X equals 1 has an output of -1 and also -5. Not a function. Okay, and you can see it right here hitting 2 places at once. Okay, let's try another one. Okay, this one. Is this one a function? Well, if I pass a vertical line over this curve, do I ever hit 2 points at once? No. No, we're good. So this one is a function because it passes the vertical line test. Submit answer. It's a function. Yeah. See, watch when that line goes through. It only ever hits 1 point at a time. So therefore, it's a function. Okay. Let's go back and look at the determine if a set of points is a function. Okay. Which set of ordered pairs does not represent a function? So just go back on that definition. Is there a place in any of these, well, the one that's not going to be a function, it will have the same x value going to two different y values. Okay, so let's see. See if we can find it. I assume one, let's see, which set of ordered pairs does not? So it must be one of them. Oh, right here. Okay, so remember our definition. In a function, each x value can only go to one y value. But look, down here in this one, the number 2 is associated to the number 0 for a y value. And then the number 2 is also associated to -6 as a y value. So we just saw this graphically where they line up vertically on the graph. But here it's the same as just saying, look, 2 goes to 2 different y values. So therefore, this is the one that is not, a function. And yep, they pick it out right here, the 2's. Actually, It's actually, their explanation here doesn't seem fantastic. But so that's the idea. You're just looking for an x value repeated with a different y value. That's how you do that one. Okay, does that make sense? If that's unclear, we can talk about it more. Okay, then we have a few more questions. Linear function context questions from table. Okay, let's take a look at that. So some of these are slight variations of homework problems, but they're not like completely new topics or totally new things I'm throwing at you, right? It's sort of different variations of the same types of problems. So they might be slightly different than what you've seen before, but they're pretty much the same thing. Let's see. What was that I was looking at? And it's totally great to ask questions. You keep putting them in chat, and so we'll just be ready to go over more stuff. As soon as I talk about stuff, we can go right into the next stuff and cover as much stuff as you all need to see. Linear function context from table. Linear function context from table. Okay.
The linear functions from the context from table, that one's a new one too. I'm going to mention that.
Sure. Right. So let's see. So like I say, some of these are just sort of slight variations on ones we've already seen. But yeah, we can look at that one. Let's see. The weight in pounds of a newborn baby T months after birth can be modeled by W. The table below has select values showing the linear relationships between T and determine the number of pounds the baby gains per month. So all this is just a different version of the problem that gives you some points and says find the line. Because these are just points written in table form, right? So it's not really like new math that you have to do. Determine the number of pounds the baby gains per month. So basically, this is a slope problem. This is just find the equation of this, or not even find the equation, find the slope, right? So all you have to do is use the slope formula on this. So let's see. We're going to pick two of these 3 points. So you remember slope back from the very beginning when we would do slope? This is a point. This is a point. In fact, you do have a problem on the test that is find the equation of the line through 2 points. We definitely did that in class. For sure, we did that in class because I always show that one in class, and I'm sure you had homework problems on as well. But you're just taking the 2 points and finding the slope. So let's see, A to 18. And let's see, 1, 7.5. So I'll just take the first and last point, and then we'll find the slope to them. So let's see. Okay, so we've got the points 1, 7.5 and the point 8, 18. Let's see. Let's double check I read the problem right. Yeah, between T and W. Right. Okay, so to find the slope, remember it's y2 minus y1 over x2 minus x1. So we're going to have what? 18 minus 7.5 over 8 minus 1. It's not, is it? Let's see. There we go. Okay, so here's our, oops, and that should be a comma right here. So 18 minus 7.5, 8 minus 1. So when we simplify that down, it's going to become, what, 18 minus 7.5 is going to be 11.5 over 7. And how do they want the answer? Let's see. They want it in decimal form, it looks like. So let's see. If we've got, oh, why is it not compiling? So 11.5 divided by 7. It's about 1.64. Remember, let's see. I forget how they want it. Let's do 11.5 divided by 7. 11.5. pounds per month. Let's see, what did I do? Oh, because 10.5, isn't it? Yeah, it's 10.5. That's where I made my mistake. Should be 10.5 over 7. So let's see if it likes that. 10.5 divided by 7. What did I do? Oh, 10.5 divided by 7. Oh, they just wanted in that simplest form. So 10.5 over 7 was the correct value. They just wanted in decimal form. Right? So really all they're doing is they're giving you points on a line and you're figuring out the slope. So nothing fancy there. My answer was not fully simplified. Okay. Well, I would argue it's simplified. Well, we don't usually want to put decimals in the fraction there. And then that's just how you do that problem. Okay. Good question. Let's take a look. Then there was another one. Solve linear systems graphically level 2. Okay. Solve linear systems graphically level 2. So couple of skills here. There's both the systems of equation skills, but also you have to be able to graph the lines, right? That's really important in everything, even statistics, which doesn't use a lot of algebra. You do graph lines in statistics. So that is a skill going forward that you absolutely have to be able to do, right? You basically won't be able to get through an algebra course if you can't graph lines. So that's really important. So solve the following systems of equations graphically. So this one is in slope-intercept form. So that one's pretty easy. We're going to start off at 0, -2. So there's a point. And then the slope is -2. So I'm going to start here, and then I'm going to go down 2 over 1. Wait. Down 2 over 1. So that should be our line for this one, right? -2. And the slope is down 2 over 1. Okay, so that should be our first line, which is y equals -2x minus 2. All right, how would I do this one? X minus y equals -7. There's two ways you can do this. One, you could make a table, and just like the table we just saw in that last problem, you just create a set of points in the table, or you put it in slope-intercept form. I don't care which way you do it, but you got to be able to do one of them. So x minus y equals -7. Let's look at that. X minus y equals -7. So then we go, let's subtract. Let's see, what do I want to do? It doesn't really matter. There's a few ways you could do this. Why don't we add y to both sides? So x equals y minus 7. Right? And then we'll add 7. So x plus 7 equals y. Which, of course, we could also call y equals x plus 7. Some people feel much more comfortable if they switch it around so it's really in that slope-intercept form. Some of you can look at this and realize, oh, the slope is 1 and the y-intercept is 7. Some people really like to put it in that y equals mx plus b form. It doesn't matter. Whatever works for you, that's what you should do. Okay? So we're seeing a slope of 1 and an intercept of 7. So if I come over here, intercept of 7 and a slope of 1. So there's my two lines. Remember, the point of intersection of two lines is the solution to that system of equations. Okay, so that looks to me like it's -3, 4. All right, let's plug those in and see if they work. So -3 would give me 6 minus 2 equals 4. Yeah, -3, 4 works in the first one. Let's see if it works in this one. -3 minus 4 equals -7. Yep. So we know we got the problem right. So let's see. -3 comma 4. And there we go, right? So for this problem, you just graph the two lines, look at the point of intersection, and go from there, right? So you can see what they did. They put them both in slope-intercept form like I did. But also, if you just want to pick some x values and plug it in and figure out what the y value is and plot some points and draw a line through it, that works too, right? So, in fact, the way you graph on here using the tool is by literally picking 2 points. So that would work too, to just plot some points. So that totally works as well. All right, what else can I go over for you? We got plenty of time to talk about some more problems. Questions? So remember these for cubics? When you're going to factor these, factor that greatest common factor first, right? Looks like you could take a 2x out of everything. Do that first. The rest will get a lot easier. So always look for that. Remember, when you're solving, when you solve equations by factoring, you're setting the factors equal to 0 and going from there. Oh, piecewise functions. We talked about piecewise. Oh, here we go. Yeah, so right. So there's a comment, I can't believe how much I forgot from early on. Yeah, and that's exactly why the studying is so important, because I find even if it's as short as like 4 weeks, students will master a topic and they like totally know it. And then if you don't look at it for 4 weeks, you just start to forget it all. And the good news is it comes back fast. If you actually learned it right the first time, it'll come back really fast to you. Sometimes it's as simple as you go back and do one problem from that section and you go, oh, now I totally remember it. If you only kind of learned it the first time, then, you know, usually you're still going to be a little bit rusty on it when you go back and review it. Sometimes you'll have learned stuff in the meantime where that section makes more sense to you than it did at the time. But if you really put in the effort at the time and learned how to do a certain type of problem, then usually it comes back very quick. Like it's just a tiny fraction of the amount of time to review as it was to originally learn it, right? That's less so if you're just memorizing problems, then your brain doesn't really like retain it in the same way as if you really learned how to do it properly. But yeah, it's very easy to forget stuff that you learned before, but luckily it comes back fast. Context inequality systems graphically. Great. I was kind of looking at that. I was surprised no one asked that. Let's go over it. Level 1. Okay, so we did a couple of these in class, but they were confusing. There's a few different things going on, so it's totally, I'm actually glad this was asked. So the drama club is selling tickets to their play to raise money for the show's expenses. Okay, so it's a fundraiser. All right, got it. Each student ticket sells for $5, and each adult ticket sells for $8. Okay, so we got two different sets of prices. Okay, the auditorium can hold 150 people. So at this point, like I haven't read the whole problem, but I'm starting to kind of piece together what I think's going on. I think we're going to have, we have two different prices. So my guess is we're going to have we're probably going to have the number of kids tickets sold, the number of adults tickets sold. They have different prices, and the auditorium can hold 150 people, meaning the assumption here is you can't sell more tickets than the auditorium can hold. So there's a maximum right there. There's a constraint. So I'm already thinking, ooh, I bet that's my constraint on my variables, one of my constraints right there. Okay. The drama club must take in at least $960 from ticket sales to cover the show's costs. Okay, so in other words, let's see. If all you sold was student tickets, then that would be what, $750? $750 is less than $960, meaning the school just lost money. And schools already don't have money. They can't afford to lose more money. So in other words, we can't just sell all the students. And you'd go, well, it'd be nice to sell all to adults, but like you probably want students showing up and watching it as well. You want like a mixture, right? So what are the mixtures that are going to allow us to at least break even is what we'd like to know. Oh, and they're even giving us the variables here. If X represents the number of tickets sold and X represents the number of student tickets sold, Y represents the number of adults tickets sold. They're telling us this in the problem. Write and solve a system of inequalities graphically and determine determine one possible solution. Okay, well, let's see. What do we know? So notice we have to put it in slope-intercept form. So probably you're going to have to do a little bit of scratch work off to the side to make sense of this. So what do we know? We know that X is student tickets, the number of student tickets. Y is the number of adult tickets. And there can only be 150 tickets sold. So in other words, that tells us that X plus Y is less than or equal to 150. Right? Number of student tickets plus the number of adult tickets has to be less than or equal to 150. You can't sell more seats than that. You might sell less, right? This is generally what happens in these kinds of things, is there's some empty seats. Excuse me. But that's okay. So let's put this in slope-intercept form. We're just going to subtract X from both sides. Y is less than or equal to 150 minus X. Y is less than or equal to 150 minus X. Okay, so let's go back to here. Y is, so I choose the less than or equal to 150 minus X. And then it even plots that for us. But we have to figure out which side we're shading. Because remember, we're not just graphing a line. These inequalities are on the solutions on one side or the other. So we have to figure out, let's see, which side should we shade on? Well, let's just pick a point like 10, 10. That's what you do. You pick a sample point. So 10, 10. What if I plug this in? Is 10 less than or equal to 150 minus 10? Yeah, it is. So that means we want to shade that side of things. Okay, great. That problem's done. Now we have the one that's going to take a little bit more work in order to graph. So let's see. Okay, so we know we have to make $960 in sales, and we know how we're making it. For each student ticket, we get $5. For each adult ticket, we get $8. And X is the number of student tickets, Y is the number of adult tickets. So this one will become okay, so then we have 5X plus 8Y. So 5X is the amount of money generated from selling student tickets, right? Because it's $5 times each student ticket. 8Y is the money generated from selling adult tickets, because it's 8 times Y. And that has to be greater than or equal to, was it 950? 960. Okay. 960. Okay. Oops. Okay, so 5X plus 8Y is greater than or equal to 960. All right, so that's not in the right form yet. We need to get that in the right form. So let's subtract 5X from both sides. So I'm going to get 8Y is greater than or equal to 960 minus 5X. All I've done is subtract 5X from both sides. So now I'm going to divide everything by 8. So Y is, and I'm dividing by a positive, so we don't have to flip the direction of the inequality, but you might have to in a problem that you do. This is going to be, what is it, 5/8? Yeah, because we're dividing by 8. Oops. 5/8 X, so this will be minus that. And then what is 960 divided by 8? It's 120. So it's 120 minus that. There we go. Finally. It was not wanting to update. Okay, so Here I subtracted the 5x from both sides. Here I divided by 8. So 120 minus 5/8 x. So let's see. 120 minus 5/8 x. So we plot that. We've got this. And then we have to figure out which side to shade on. I think it's going to be this one up here. But let's just double check. Why don't we take the point, say, let's see, just pick any point. How about we do, let's see, what would be a good one to, let's see, if we had 8, something that was 8. It doesn't even matter. We'll just do like let's say 200, 100. So our x value is 200, our y value is 100 for our test point. So if I plug that in there, if I do 5/8 times 200, I get 125. So 120 minus 125 is less than or equal to 100. Yeah, so you just do your test point, and that means we shade this side. That means the points that satisfy both of these conditions lie in this doubly shaded part over here, right? This section doesn't satisfy any conditions. This one satisfies the conditions that we made enough money, but, you know, it doesn't satisfy the seating conditions. This will generate enough money, but we can't sell 200 tickets, right? We're not allowed 200 adult tickets and 200 child tickets. We're not allowed to do that. This one satisfies the number of seats sold, but doesn't raise enough money. This is the zone that does both. It raises enough money, and it doesn't sell more tickets than it can seat. Okay, so all you have to do now is pick a point in here. So how about 40, 100? So the drama club could sell 40 student tickets and 100 adult tickets. I think that's right. 40. Yeah, that should work. Submit answer. Yes, and it likes it. Okay. So same idea that this looks familiar. And see the yellow dots? That's where, at the little grid lines, that's where our solutions exist. Because technically, you probably could get away with putting some in here. You can't sell a fractional number of tickets, but you could do them in increments smaller than 10. But it's a little harder to see, right? So that's how you do that problem. Really, really good question. Is there any other problem people want to see? I still probably could at least cover something with the time left. Cubics. Yep, let's do that. So I think I kind of mentioned one a minute ago, but let's go over those. Absolutely. And any other stuff, if people want to throw them in there, I mean, if we go a few minutes over and people have questions, well, we can definitely do that. Okay. So for this one, the key is to factor out the greatest common factor. Yeah, cubics. You're generally going to be factoring out the greatest common factor. So it's 2x cubed minus 8x squared minus 10x. Okay. So let's go factor 2x cubed minus 8x squared. Was it minus plus 10 or something? 2x cubed minus 8x squared. 2x cubed. X cubed minus 8x squared minus 10x. Okay, so this one seems confusing until you realize we have to factor out the greatest common factor. By doing that, I get, so the greatest common factor there is 2x. So I factor out a 2x. That leaves me with an x squared minus 4x plus 5. Okay. And then we just keep writing this 2x in front, but we don't really have to do anything more with it. If we were solving, we would. We'd have to set that 2x equal to 0, right? But we don't have to, because here we're just factoring, not solving. Remember that? This is a common mistake I see on these tests. Remember the difference between factoring an expression and solving an equation. I see students sometimes, they clearly know what they're doing, but they do the wrong one at the wrong time, or they do the right one at the wrong time, or however you want to state that. They do it wrong. So make sure you know the difference between solving an equation, factoring an expression. And then now we're just going to factor what's in the parentheses. So that's going to be what? X minus 5, x plus 1. let's see, is that right? So should be plus x minus 5x. Oops, that's not right. Let's see. So it's going to be, did I do that right? Let me see. Oh, because I did plus. It is supposed to be a minus 10x. There's my typo. Okay. That wasn't going to make sense, but now it does. So this really should be a minus right here, meaning this now makes sense. So does everyone see? I had the problem written down wrong, which again, big thing you got to be careful about. But my problem was looking like it wasn't going to be factorable, so I went back and double checked. Did I write this down right? And I found my mistake. That minus was a plus when I wrote it. And that looks right. So 2x, x minus 5x plus 1. And here we go. Okay, so with those trinomials, all the ones I've seen that it gives in this section are you got to just do the greatest common factor first. So once you take out that greatest common factor, you're good to go. Okay, any other questions that people have or things you want to ask about? Okay, then. If not, feel free to stick around. I will remind you, I have office hours tomorrow. So I fully invite all of you to come, whoever wants to come tomorrow. Like, look over the practice test a little more, see what you can do with it. Come to my office hours tomorrow and ask me questions, right? Just like we just did here. I'll sit here and help you work through these problems so that you understand how they work, okay? So that you can make sense of them. Okay? So with that, anyone who wants to stick around in Zoom and talk to me about whatever, feel free to do that, right? The test is kind of a big scoring time in the class. It'll affect your grade significantly, so I want to make sure that I'm available to help you get that completed. So talk to me now, talk to me tomorrow, get help from the tutors on campus or with their Zoom meetings, whatever you need in order to be prepared for that test. Okay, thanks everybody. We'll see you later.